So if you remember, we started first semester with the idea of, well, what's the equation for a line tangent to a curve at one point? That was really hard to figure out. But once you figure it out, we're able to apply it to all sorts of different cool situations, and that's differential calculus. Well, this becomes integral calculus. So let's look at your probably most basic example you're going to see, okay? And that's of x squared. We want to find the area bounded beneath x squared and the x-axis and the line x equals 4. Now, I already introduced to you guys right-hand sum, left-hand sum, and trapezoidal sum, correct? We're really not going to think about that too much for a couple more days. Right now, I just want you to focus on this. We're going to say everything is right hand. So right hand 2, right hand 4, and right hand 8 rectangles. This is f of x is equal to x squared. And we learned from our investigation that you can take the width of the rectangles multiplied by the sum of the heights. Is everybody with me? Okay. If I'm going to have two rectangles in this region, what's going to be the width? 2. How do you get that? Yep, 4 divided by 2, I get 2, times the sum of the heights. So I'm going to mark off, so I've got 2 here, I've got 0 there. I'm going to focus on right hand. So where do I want to evaluate the height of my first rectangle? I want to evaluate it at 2. Very good. So are we going to get overestimations here or underestimations? We're going to get over in this situation. Some people might say, well, right hand will always be overestimation. Nope, not always. So, great. So what's the first height? 4. How do you get that? And what's the second height? 16. Very good. So I get 2 times 20 is 40. Now I'd like to do, instead of 2 rectangles, I'd like to do 4. What's the width going to be? 1 times. So now I'm going to lay these out. I've got 1, 2, 3, 4. So where do I evaluate my first height? 1, then 2, then 3, then 4. You can see that the red rectangles are a better estimation than the blue ones, right? I mean, we get rid of some of this excess area, so that's good. So we got 1 plus 4 plus 9 plus 16, right? That makes a total of 30. Yeah, because it's 4 units wide, and we're dividing into 4 parts. So the width here is it's 4 units in width, the entire interval, and we're going to divide it into 8 rectangles. So what's the width going to be altogether? 1/2. Now, so 1/2, so now I've got 1/2, 3 halves, 5 halves, 7 halves. That's going to be my halfway spot between those. So where do I evaluate my first height? 1/2, and then 1, 3 halves, 2, 5 halves, 3, 7 halves. Okay. Well, that's a little bit more work, isn't it? But we kind of just got to do it. So we got 1/2 squared plus 1 squared plus 3 halves squared plus 2 squared plus 5 halves squared plus 3 squared plus 7 halves squared plus 4 squared, right? Okay, so that's 1/2 times. Well, I know the 1 squared, the 2 squared, the 3 squared, the 4 squared, that adds to 30, doesn't it? So I'll just do the other parts now. And however you want to navigate through these type of problems, up to you. But 1 divided by 2 squared, that's going to square the whole thing, plus 3 divided by 2 squared. No, it's just going to square the denominator. 1 divided by 2 squared. 3 divided by 2 squared. 5 divided by 2 squared. And then 7 divided by 2 squared. And I get 21. So that's 51 over 2, which is 25.5. So we overestimation or underestimation. You can tell by the picture, right? Now, if you want to know the exact area, you could just go in here and type in x squared, and then second calculate, and we do number 7. And where are we bounding this from? 0 to 4, and you can see it's going to calculate to be 21 1/3. So we're still off, but we're getting better each time, aren't we? Yeah. Well, see, the 1 squared, 2 squared, 3 squared, 4 squared, that was this part, right? So I knew I got 30 out of that. And I just did the 1/2, 3/2, 5/2, 7/2 on So did you get the general idea of what we're doing? Okay, so then tomorrow we're going to pick up with using tables and some other pieces. You're going to be given some time to work in class. And then on Thursday, we're going to get really to the right-hand, left-hand, midpoint, and trapezoidal self-piece, okay? To do an infinite number of rectangles, there is an equation that we use, so to speak, but really the equation is this, B. Rody. The equation really is the width times the sum of the heights. It really is. But if you notice, just to see, so you had up here, you had 4 because that was the entire interval, right? So the width of this interval is b divided by, or b minus a, right? And then you divide it by the number of rectangles. Well, we divide that by n, and we let the limit, we let n go to infinity is what we do. And it seems ridiculous that it could work out, because the width gets infinitely small, but the area comes out exact. And you're going to see it. And when you do, there's people who look at the formula and they're just like, oh, well, it's a formula, I'll just follow it. There's other people who look at it and they can see that you're actually calculating the infinite, which is, oh, that's what the word calculus means.